Close your eyes and imagine the night sky above you. Stars scattered like diamonds on black velvet. Each point of light tells a story of fire and fusion, of nuclear hearts beating across impossible distances. But tonight, your thoughts drift beyond what you can see. Beyond the gentle glow of familiar constellations. Into the spaces between the stars, where something extraordinary hides in plain sight. In those dark regions, invisible to your eyes, live the universe's most mysterious objects. They have no surface you could touch. No light you could follow. No sound you could hear. Yet they are among the most powerful forces in all of creation. These are black holes. And they are calling to you from the darkness. Picture this: somewhere in the vast ocean of space, there exists a place where the rules you know begin to bend. Where up and down lose their meaning. Where time itself slows to a crawl, like honey on a winter morning. You cannot see this place directly. It reveals itself only by what it does to everything around it. Like a whirlpool in a calm river, it pulls and twists the very fabric of space and time. Imagine you are floating in a small boat on perfectly still water. Suddenly, you notice something strange. The water around you begins to move in gentle circles. Faster and faster the circles grow. The current pulls at your boat, drawing you toward something you cannot see beneath the surface. This is how a black hole announces itself to the universe. Not with light or sound, but by the way it commands everything around it to dance. Stars that venture too close begin to stretch like taffy. Gas clouds swirl in brilliant spirals before disappearing into nothingness. Even light, the fastest thing in the universe, cannot escape once it crosses an invisible boundary. This boundary has a beautiful name. Scientists call it the event horizon. Think of it as the shore of a cosmic ocean that has no other side. Once you step into those waters, there is no coming back. You would fall forever, through space that curves back on itself like the inside of a sphere. But do not let this frighten you. These cosmic whirlpools are not monsters lurking in the dark. They are more like ancient guardians, keeping watch over the galaxies. They help shape the very neighborhoods where stars are born. Your own galaxy, the Milky Way, has such a guardian at its center. A massive black hole, millions of times heavier than our Sun, sits quietly in the galactic heart. It has been there for billions of years, longer than Earth has existed. From your home planet, this giant is impossibly far away. So distant that its powerful pull feels no stronger than a gentle breeze. You orbit the Sun in perfect safety, protected by the kindness of space itself. Yet even from this safe distance, you are connected to that distant guardian. You and every atom in your body travel together on a grand journey around the galactic center. One complete orbit takes about 225 million years. This means that during your lifetime, you barely move at all in cosmic terms. You are like a passenger on an enormous, slow-moving ship, sailing through seas of stars. But black holes are not always content to sit alone in the darkness. Sometimes, across the vast reaches of space, two of these invisible giants find each other. They begin a dance that can last for millions of years. At first, they circle each other at great distances, like shy dancers at opposite ends of a ballroom. But something remarkable happens as time passes. They grow closer with each orbit, pulled together by the same force that keeps your feet on the ground. As they spiral inward, their dance becomes faster, more intense. Space itself begins to ripple around them, like waves spreading out from stones dropped in a pond. These ripples carry energy away from the dancing pair, causing them to move closer still. The waves they create are unlike anything you have ever experienced. They are ripples in the fabric of reality itself, stretching and squeezing space as they pass. They travel at the speed of light, crossing the entire universe, carrying news of this cosmic dance to anyone who knows how to listen. These gravitational waves, as scientists call them, have been washing over Earth for as long as our planet has existed. They pass through you right now as you rest, as gentle and unnoticed as morning sunlight streaming through a window. For most of human history, these waves remained a secret. They were too small to detect, too subtle for our instruments to feel. But in recent years, brilliant minds have built machines sensitive enough to catch these whispers from the deep. When two black holes finally embrace, in those last moments of their million-year courtship, they release more energy than all the visible stars in the universe. For a brief instant, their collision outshines entire galaxies. Yet here on Earth, that tremendous violence arrives only as the gentlest touch. The waves that reach you are so small they would barely disturb a single atom in your body. This is the beautiful paradox of black holes. They are both the most powerful and the most peaceful presence in your cosmic neighborhood. Violent beyond imagination, yet so distant that they rock you to sleep with whispers softer than a mother's lullaby. Tonight, as you rest, remember that you live in a universe where such wonders dance just beyond sight. Where invisible giants write poetry in the language of gravity itself. The darkness between the stars is not empty. It is full of mystery, full of stories waiting to be discovered. And somewhere in that darkness, ancient forces are stirring, preparing to tell you secrets about the very nature of space and time. Take a deep breath and let your mind wander to a place that seems impossible. A place where nothing weighs more than everything. Where emptiness becomes the heaviest thing you could ever imagine. This is the heart of a black hole. A region so dense, so concentrated, that it defies everything your everyday experience tells you about the world. Picture yourself holding a marble in your palm. Feel its smooth surface, its gentle weight. Now imagine taking that same marble and somehow squeezing it down to the size of a grain of sand. Then smaller still, to the width of a human hair. Keep going, smaller and smaller, until it becomes a point so tiny it has no size at all. But here is the remarkable thing. Even though this point takes up no space, it still weighs exactly the same as the original marble. All that matter, all that substance, compressed into something smaller than the smallest thing you can picture. This is what scientists call a singularity. The mysterious center of every black hole. A place where all the rules seem to break down, where mathematics itself begins to whisper secrets it cannot quite speak aloud. But you do not need to travel to the center to feel a black hole's strange power. Long before you reach that impossible point, you encounter something equally wonderful. The bending of space itself. Imagine you are walking across a perfectly flat field on a sunny afternoon. The ground beneath your feet is solid, dependable, level in every direction. Now picture someone placing an enormous bowling ball in the center of that field, so heavy it creates a deep dip in the earth around it. If you roll a smaller ball across this field, it will not travel in a straight line anymore. Instead, it will curve around the depression, following the new shape of the ground. The heavy ball has changed the very landscape through which everything else must move. This is exactly what a black hole does to space and time. Its incredible density creates a deep well in the fabric of reality itself. Space curves inward, bending like a stretched rubber sheet around a heavy stone. Time, that steady companion that marks your days and nights, begins to act strangely near this cosmic well. It slows down, stretching like warm honey on a winter morning. What feels like minutes to you would feel like hours to someone watching from far away. If you could somehow approach a black hole safely, you would experience this time bending firsthand. Your heartbeat would slow. Your thoughts would become leisurely and dreamlike. The distant stars would appear to speed up in their courses, racing through years in what feels like moments to you. This is not science fiction. This is the beautiful, strange reality of our universe. Time and space are not separate things. They are woven together into a single fabric that can stretch, bend, and flow like water. Einstein discovered this truth more than a century ago, though it took decades for scientists to find proof. He showed us that massive objects do not just sit quietly in space. They reshape the very stage on which the cosmic drama unfolds. Near a black hole, this reshaping becomes extreme. Space curves so sharply that it eventually curves back on itself. Like a paper cone that closes into a complete circle, space forms a boundary from which nothing can return. This boundary, the event horizon, is not a physical surface you could touch. It is more like an invisible line drawn in the geometry of space itself. Cross this line, and you find yourself in a region where all paths lead inward, no matter which direction you try to go. Think of it like being in a river where the current flows faster than you can swim. No matter how hard you paddle upstream, you are carried toward the waterfall. Near a black hole, space itself flows inward faster than light can travel outward. But from your safe distance here on Earth, these cosmic waterfalls appear almost peaceful. They sit quietly in the darkness, invisible except for their influence on everything around them. Like gentle giants, they shape the motion of nearby stars and gas clouds through pure gravitational embrace. The nearest black hole to your home world lies about 1,000 light-years away. This may sound close in cosmic terms, but it represents a journey longer than human civilization has existed. At the speed of our fastest rockets, it would take millions of human lifetimes to reach. Yet even from this vast distance, that black hole and countless others like it play a role in your daily life. They help maintain the structure of your galaxy, keeping stars in their proper orbits. They regulate the birth of new stars and the recycling of old ones. In a sense, black holes are cosmic gardeners, tending the vast spaces between stars. They prune away excess gas and dust, creating the calm neighborhoods where planets like yours can form and thrive. The matter that falls into a black hole does not simply vanish. It joins the singularity at the center, adding to the invisible weight that holds the cosmic garden in balance. In this way, black holes grow slowly over time, becoming more massive and more influential with each passing eon. Some black holes have been growing for billions of years, since the universe was young and wild. They have witnessed the birth and death of countless stars, the formation of entire galaxies, the slow evolution that led to worlds like yours. These ancient guardians carry within them the compressed history of cosmic time. They are libraries of gravity, storing information about everything they have ever encountered in the strange mathematics of their event horizons. As you rest tonight, surrounded by the familiar weight of Earth's gravity, remember that you live in a universe where nothingness can be heavier than the heaviest mountain. Where empty space curves and flows like ocean currents, carrying you on journeys you cannot feel. The void between stars is not truly empty. It is full of invisible currents and hidden depths, shaped by the presence of these cosmic wells that draw everything toward their timeless embrace. In the beginning, there were no black holes. The universe was young then, filled with the first generation of stars. These ancient suns burned bright and fierce, much larger than the gentle star that warms your world today. Picture a star in its prime. Deep in its core, a cosmic furnace burns at temperatures beyond imagination. Hydrogen atoms crash together with tremendous force, fusing into helium and releasing the energy that makes the star shine. This nuclear fire creates an outward pressure, like air filling a balloon. It pushes against the star's own gravity, which constantly tries to pull everything inward toward the center. For millions or billions of years, these two forces dance in perfect balance. The star lives in harmony with itself. Gravity pulls inward. Nuclear fire pushes outward. Neither wins, neither loses. The star shines steadily, a beacon of light in the cosmic darkness. But stars, like all living things, eventually grow old. They begin to run out of the hydrogen fuel that keeps their fires burning. Without enough energy pushing outward, the balance begins to shift. Imagine a person holding up a heavy weight above their head. For a while, their muscles are strong enough to keep the weight in place. But as they grow tired, their arms begin to shake. Eventually, they cannot hold the weight any longer. This is what happens to a massive star when it runs out of fuel. Its nuclear fire begins to weaken and flicker. Gravity, patient and relentless, starts to win the ancient battle. At first, the star tries to save itself. It burns heavier elements, creating new types of fuel from the ashes of the old. Carbon burns to make neon. Neon burns to make oxygen. Oxygen burns to make silicon. Each new fuel burns faster and hotter than the last. What once took millions of years now happens in thousands. Then hundreds. Then mere seconds. The star races through its remaining lifetime like a candle burning at both ends. Finally, the star reaches a moment of cosmic desperation. It tries to burn iron, the final element in its nuclear arsenal. But iron refuses to burn. It absorbs energy instead of releasing it. The star's last hope crumbles like sand through its fingers. In that moment, gravity claims its ultimate victory. The star's core, no longer supported by nuclear fire, collapses inward at incredible speed. Matter falls toward the center faster than sound, faster than thought. The collapse happens so quickly that the outer layers of the star have no time to react. They continue shining peacefully, unaware that the ground beneath them has vanished. Then the shock wave arrives, racing outward at tremendous speed. This is how a supernova is born. The collapsing core bounces back against itself with unimaginable force, sending a blast wave through the star's outer layers. In a matter of hours, the star becomes 1 billion times brighter than it was before. For weeks or months, this dying star outshines its entire galaxy. It becomes visible across cosmic distances that light takes billions of years to cross. It announces to the universe that something extraordinary has just occurred. But the real magic happens in the core, where the original collapse continues. Nothing can stop it now. The matter there becomes so compressed that atoms themselves are crushed out of existence. Imagine squeezing a grape until it becomes smaller than a grain of rice, but still weighs exactly the same. Then squeeze that grain of rice until it becomes smaller than a speck of dust. Keep squeezing until it has no size at all, yet retains all its original mass. This is the birth of a singularity. A point in space where matter becomes infinitely dense, where the normal rules of physics break down and whisper of deeper mysteries. Around this impossible point, space itself begins to curve so sharply that it forms a boundary. This boundary, the event horizon, marks the edge of a newborn black hole. It is invisible, marking not a place but a point of no return. The black hole that emerges from this cosmic catastrophe may be only a few miles across, but it contains the entire mass of the original star. All that matter, compressed into a space smaller than a city. From this moment forward, the black hole will exist essentially forever. Unlike stars, which burn out and die, black holes grow stronger with age. They pull in matter from their surroundings, adding to their mass and influence. Some of these newborn black holes find themselves in busy neighborhoods, surrounded by gas clouds and companion stars. They begin feeding immediately, pulling material into glowing disks that spiral inward like cosmic whirlpools. Others are born in quieter regions of space, far from any source of food. They sit patiently in the darkness, invisible and almost forgotten, waiting for the slow dance of galactic motion to bring them new encounters. Over billions of years, some black holes grow to enormous sizes. They swallow entire star systems, merge with other black holes, and eventually take up residence at the centers of galaxies. The black hole at the heart of your own galaxy weighs as much as 4 million suns. It formed long before Earth existed, growing slowly through cosmic time until it became the massive anchor point around which hundreds of billions of stars now orbit. But not all black holes are giants. Many remain roughly the size they were when they first formed, patient and eternal, scattered throughout the galaxy like invisible seeds planted by ancient supernovas. These stellar mass black holes are your closest neighbors in the cosmic community of collapsed stars. They drift silently through space, marking the final resting places of suns that died before your solar system was even a whisper of possibility. Each black hole carries within its event horizon the complete story of the star that created it. All the elements that star forged in its nuclear fires, all the light it cast across space, all the time it spent burning in the darkness. In death, these stars become more mysterious than they ever were in life. They transform from sources of light into absorbers of light. From creators of energy into collectors of energy. From temporary flames into eternal wells. The universe has been creating black holes for billions of years. Each generation of massive stars adds new members to this invisible population. They accumulate over time like interest in a cosmic savings account. Tonight, as you rest beneath stars that still burn bright and warm, remember that you live in a universe where even death can lead to something eternal. Where the end of one story becomes the beginning of a mystery that will outlast the stars themselves. Somewhere in the darkness above you, These children of collapsed stars are beginning to find each other, drawn together by the same force that keeps your feet planted firmly on the ground. Imagine two dancers meeting for the first time in a ballroom larger than you could ever picture. The floor stretches beyond horizons, beyond galaxies, beyond the edge of imagination itself. The music that guides their steps is the silent rhythm of gravity. These are not ordinary dancers. They are black holes, born from the deaths of ancient stars, now finding each other across the vast emptiness of space. Their meeting is rare and beautiful, a cosmic coincidence that takes billions of years to unfold. At first, they circle each other at enormous distances. They are shy partners, separated by spaces wider than entire solar systems. They move slowly, taking millions of years to complete a single orbit around their shared center. You cannot see them with your eyes. They cast no light, make no sound, leave no trail across the sky. Yet they are there, two invisible weights in the fabric of space, pulling at each other with patient, relentless attraction. The dance begins simply. Each black hole follows an elliptical path, like planets orbiting a star. But this is different from the steady, predictable orbits you know. These dancers are slowly falling toward each other, caught in an embrace that grows tighter with every passing age. As they circle, something magical happens. Their massive bodies create ripples in space itself, like stones dropped in a perfectly still pond. These ripples carry energy away from the dancing pair, spreading outward at the speed of light. Each wave that flows away makes the dancers move a little closer together. It is as if the music of their waltz is made from their own energy, and with every note they play, they give up a small part of themselves. This process is so gradual you would need the patience of mountains to watch it unfold. Over millions of years, the two black holes spiral inward, their orbits shrinking like the circles of water around a closing drain. Think of two figure skaters spinning together, holding hands and pulling closer. As they move toward each other, they begin to spin faster. The same thing happens to the dancing black holes. As their orbits shrink, their dance accelerates. What once took millions of years to complete now happens in thousands. The gravitational waves they create become stronger, carrying away more energy with each pulse. The dance becomes more urgent, more intense, more beautiful. The black holes begin to feel each other's presence more directly. Their event horizons, those invisible boundaries from which nothing returns, start to stretch and pull toward each other. Space itself becomes distorted by their cosmic courtship. Time, that steady river that flows through your daily life, begins to behave strangely near the dancing pair. It moves more slowly in the deep gravitational wells they create, like a river flowing uphill. The closer they get, the more time itself becomes part of their dance. If you could somehow watch from a safe distance, you would see the final phase of their billion-year romance compressed into moments. The black holes would appear to spiral inward faster and faster, like leaves caught in a whirlpool. But time plays tricks near such massive objects. What looks like seconds to you would feel like hours to anything caught in their gravitational embrace. The dance happens in slow motion from one perspective, lightning fast from another. As the two black holes draw within a few hundred miles of each other, their dance enters its final, most dramatic phase. They are now moving at significant fractions of the speed of light, racing around each other dozens of times per second. The gravitational waves they create become intense, carrying away enormous amounts of energy with each pulse. These waves reshape space itself as they pass, stretching and squeezing the fabric of reality in patterns that mirror the cosmic dance that creates them. In these final moments, the black holes begin to lose their individual identities. Their event horizons stretch toward each other like reaching hands, creating bridges of curved space that connect the two invisible dancers. The waves they generate become so powerful that they carry more energy than all the visible light from all the stars in the observable universe. Yet this tremendous output lasts only for seconds, a brief cosmic firework celebrating the end of a billion-year courtship. Then comes the moment of union. The two event horizons touch and merge, creating a single, larger black hole. The dance ends not in separation, but in perfect unity. Two become one in a transformation that releases more energy than the explosion of a billion suns. But this energy does not appear as light you could see. It flows out as gravitational waves, ripples in spacetime itself that carry the news of this cosmic wedding across the universe. The waves spread in all directions, traveling at the speed of light through the emptiness between galaxies. They pass through planets and stars as if they were not there at all, carrying their message undisturbed across billions of light-years. These waves are incredibly tiny by the time they reach distant worlds like yours. They stretch and squeeze space by amounts smaller than a fraction of the width of an atomic nucleus. Yet they carry within them the complete story of the dance that created them. For most of cosmic history, these gravitational whispers passed unnoticed. They washed over every planet, every star, every grain of dust in the universe, but no one was listening. The universe kept its most dramatic secrets hidden in plain sight. The dancing black holes have been performing their cosmic ballet throughout the history of the universe. Countless pairs have found each other, spiraled together, and merged in explosive unions that shake the very foundations of reality. Each dance is unique, like snowflakes or fingerprints. The mass of the dancers, the shape of their orbits, the speed of their final embrace, all combine to create a gravitational song that has never been sung before and will never be repeated exactly. Some dances involve partners of equal size, creating symmetric spirals that end in perfectly balanced mergers. Others feature a large black hole slowly consuming a smaller companion, like a cosmic whale swallowing a minnow. The most spectacular dances happen when supermassive black holes, those giants that live at the centers of galaxies, find partners of their own. These cosmic titans can take billions of years to complete their courtship, reshaping entire galactic neighborhoods in the process. Tonight, as you rest in the quiet darkness, remember that somewhere in the vast cathedral of space, new dances are beginning. Ancient partners are finding each other across impossible distances, beginning billion-year waltzes that will end in unions more powerful than anything you can imagine. The universe is full of invisible dancers, writing poetry in the language of gravity itself, creating music that travels faster than light and lasts longer than stars. Right now, as you rest in the comfort of your bed, something remarkable is happening. Waves are passing through you, through your room, through the entire Earth beneath you. These are not ocean waves or sound waves, but something far more mysterious and beautiful. They are ripples in the very fabric of space and time itself. Imagine the universe as a vast, invisible ocean. Not made of water, but of something much more fundamental. Space and time woven together into a single, flowing medium that surrounds everything you know. Now picture what happens when you drop a pebble into a calm pond. Circles spread outward from where the stone touched the surface, carrying the energy of that impact across the water. The waves grow wider and gentler as they travel, but they never truly disappear. This is exactly what gravitational waves do to the ocean of spacetime. When two black holes collide somewhere in the distant universe, they send ripples racing outward in all directions. These ripples travel for billions of years, crossing the emptiness between galaxies, carrying news of that ancient cosmic dance. The waves that reach Earth today began their journey long before your planet existed. They started when the universe was young and wild, filled with the first generation of massive stars. Some of these waves have been traveling since before the Sun was born, before the Milky Way took its current spiral shape. As these gravitational waves wash over you, they do something extraordinary. They stretch and squeeze space itself by tiny amounts. The room you are in becomes fractionally longer in one direction, then shorter, then longer again, pulsing with the rhythm of the distant collision. But do not worry about feeling this cosmic massage. The waves are incredibly gentle by the time they reach you. They stretch space by amounts so small that they make an atom look enormous by comparison. You could live your entire life being rocked by these waves and never notice their touch. Think of standing on a beach as gentle swells roll in from a calm sea. The water rises and falls so slowly, so smoothly, that you barely feel the motion. You are simply lifted up and lowered down in a rhythm older than memory. This is how gravitational waves treat your world. Earth rides these cosmic swells like a small boat on an infinite ocean. The planet flexes slightly, breathing with the pulse of distant events, but the motion is so subtle that only the most sensitive instruments can detect it. For most of human history, these waves remained completely invisible. They passed through every person who ever lived, every building ever constructed, every mountain and valley and ocean. The universe was sending messages, but no one knew how to read them. Scientists suspected the waves existed long before they could prove it. Einstein predicted them more than a century ago, showing through mathematics that accelerating masses should create ripples in spacetime. But he thought they would be too weak to ever detect. For decades, brilliant minds worked to build machines sensitive enough to catch these cosmic whispers. They created instruments that could measure changes smaller than 1/10,000th the width of a single proton. These devices became some of the most precise measuring tools ever built by human hands. The breakthrough came in 2015, when scientists first heard the gravitational song of two colliding black holes. The signal lasted only a fraction of a second, but it told a complete story. Two black holes, each about 30 times heavier than the Sun, had spiraled together and merged over 1 billion years ago. The waves from that ancient collision had traveled across space for longer than complex life has existed on Earth. They passed through countless star systems, empty regions of space, and finally arrived at your planet just as humanity had learned to listen. Since that first detection, scientists have caught dozens of these gravitational messages. Each one tells the story of a different cosmic dance. Some describe the merger of black holes. Others carry news of colliding neutron stars, those incredibly dense remnants of exploded suns. Every gravitational wave that reaches Earth is unique, like a fingerprint left by the cosmic event that created it. The pitch and rhythm of the waves reveal the masses of the colliding objects, the shape of their final dance, and the distance they travel to reach you. These waves carry information that light cannot provide. When two black holes merge, they create no flash of light, no burst of radiation that telescopes can see. They announce their union only through gravitational waves, making spacetime itself their messenger. The waves also travel through space completely undisturbed. Light from distant galaxies can be blocked by dust clouds, bent by gravitational lenses, or absorbed by intervening matter. But gravitational waves pass through everything as if it were not there at all. This means they bring you unfiltered news from the most violent events in the universe. They are like cosmic time capsules, carrying perfect records of collisions that happened billions of years ago, when the universe was a very different place. As you lie in the darkness tonight, remember that you are constantly bathed in these invisible messages from deep space. Waves that began their journey when the universe was young are passing through you right now, carrying stories of ancient dances between invisible partners. Some of these waves come from nearby regions of your own galaxy, where stellar mass black holes have found each other and merged. Others have traveled from distant galaxies, crossing billions of light-years of empty space to rock your world with their gentle touch. The most powerful waves come from the collision of supermassive black holes, those giants that live at the centers of galaxies. When two galaxies merge, their central black holes eventually find each other and begin a dance that can last for millions of years. The final moments of these cosmic embraces release more energy in gravitational waves than all the stars in the observable universe produce in light. Yet by the time these waves reach Earth, they arrive as whispers softer than the gentlest breeze. Your planet has been riding these gravitational swells for its entire history. Every dinosaur that ever lived, every ancient forest that grew and died, every human who ever looked up at the stars, all were gently rocked by waves from cosmic collisions they could never imagine. Now, for the first time in Earth's history, some of its inhabitants have learned to feel these cosmic heartbeats. Humanity has developed ears sensitive enough to hear the universe's deepest secrets, written in the language of curved spacetime itself. Tonight, as you drift toward sleep, know that you are part of an interconnected cosmos where distant events touch your life in ways both profound and gentle. The universe is speaking to you through gravitational waves, sharing stories of cosmic dances that will continue long after the last star burns out. Somewhere in the vast network of space and time, new collisions are creating fresh waves that will someday reach Earth, carrying messages for generations not yet born. Picture a room so quiet that the smallest sound would seem like thunder. The walls are thick and smooth, designed to keep out every vibration from the busy world outside. Inside this sanctuary of silence, scientists have built something that seems impossible. It is a machine that can feel the universe breathing. The device stretches across miles of empty space, its arms reaching out like a giant letter L lying flat against the Earth. At the end of each arm sits a mirror, polished to perfection, waiting patiently in the darkness. These mirrors are so still they make sleeping cats look restless. They hang suspended in chambers where even air has been removed, floating in emptiness more complete than the space between stars. Nothing touches them. Nothing disturbs their perfect rest. Laser light travels between these mirrors, bouncing back and forth in an endless dance of photons. The light makes this journey thousands of times, covering distances that would stretch from Earth to the Moon. Scientists measure this journey with incredible precision, timing each trip to the smallest fraction of a second. This is LIGO, humanity's ear pressed against the universe's chest, listening for gravitational heartbeats. When gravitational waves pass through this delicate instrument, something magical happens. Space itself stretches and squeezes by amounts so tiny they defy imagination. The distance between the mirrors changes by less than 1/10,000th the width of a proton. Think about that for a moment. A proton is already unimaginably small, thousands of times smaller than the tiniest thing you can see. Now imagine something 10,000 times smaller than that. This is what LIGO can detect. It is like measuring the distance to the nearest star and noticing when it changes by the width of a human hair. The precision required seems impossible, yet brilliant minds have made it real. The laser light that travels between the mirrors acts like a cosmic ruler, constantly measuring the distance it travels. When a gravitational wave passes through, it stretches space in one direction while squeezing it in the other. The light takes slightly longer to complete its journey in the stretched direction. This tiny change in travel time tells scientists that something extraordinary has happened somewhere in the universe. Two massive objects, perhaps black holes or neutron stars, have collided with such force that they shook the fabric of reality itself. The first time LIGO felt these cosmic tremors, scientists could hardly believe their instruments. The signal appeared on September 14, 2015, at 5:51 in the morning. It lasted only a fifth of a second, but it carried news that had traveled for over 1 billion years to reach Earth. The waves told a complete story. Two black holes, each about 30 times heavier than the Sun, had circled each other for millions of years. In their final moments, they spiraled together at half the speed of light, merging in a collision that released more energy than all the visible stars in the universe. That energy flowed outward as gravitational waves, ripples in spacetime that spread across the cosmos like circles on a pond. For over 1 billion years, these waves traveled through emptiness, passing countless stars and planets, carrying their message across unimaginable distances. When they finally reached Earth, they were so gentle that they barely disturbed a single atom. Yet LIGO felt their touch and translated their whispers into something humans could understand. Since that first detection, LIGO and its sister instruments around the world have caught dozens of these cosmic messages. Each one tells a different story of massive objects dancing their final dance in the depths of space. Some signals come from black holes of equal size, creating symmetric patterns in the gravitational waves they produce. Others show the signature of a large black hole consuming a smaller companion, like a cosmic whale swallowing a fish. The most exciting detections reveal collisions between neutron stars, those incredibly dense remnants of exploded suns. These mergers create not only gravitational waves but also flashes of light that telescopes can see. For the first time, humans can watch and listen to the same cosmic event. These observations have opened an entirely new window onto the universe. Before LIGO, astronomers could only study the cosmos through light and other forms of radiation. Now they can feel the universe's gravitational pulse, sensing events that produce no light at all. The instruments that make this possible are marvels of human ingenuity. They must isolate their mirrors from every possible disturbance. Passing trucks, ocean waves, even footsteps in nearby buildings could create vibrations that would drown out the cosmic signals. To achieve this incredible sensitivity, LIGO uses systems that seem borrowed from science fiction. The mirrors float in perfect vacuum, suspended by laser beams that hold them motionless. Sophisticated computers filter out the constant trembling of the Earth itself, searching for the unique signatures of gravitational waves. The people who built and operate these instruments are like cosmic archaeologists, uncovering evidence of events that happened long before Earth existed. They work in shifts around the clock, monitoring their sensitive detectors, ready to alert the world when the universe whispers a new secret. Each detection requires careful analysis. Scientists must prove that the signal really came from space and not from some earthly source of vibration. They compare data from multiple detectors, looking for the same wave pattern arriving at slightly different times as it sweeps across the planet. When they confirm a detection, the news spreads quickly through the scientific community. Telescopes around the world turn toward the sky, searching for any visible signs of the cosmic collision that created the gravitational waves. These moments represent humanity at its finest. People from different countries, speaking different languages, working together to listen to the universe's deepest secrets. They share their discoveries freely, adding new chapters to the story of cosmic evolution. The gravitational waves that LIGO detects carry information about the most extreme environments in the universe. They reveal how matter behaves under conditions that could never be created on Earth. They test our understanding of gravity itself, confirming Einstein's predictions in ways he never imagined possible. As you rest tonight in the gentle quiet of your room, remember that somewhere in buildings designed for perfect silence, dedicated scientists continue their patient listening. They wait for the next cosmic whisper to arrive, carrying news of ancient dances performed by invisible partners in the depths of space. The universe is full of secrets written in gravitational waves, and humanity has finally learned to read this cosmic language. Let your mind drift outward from your comfortable bed, beyond the walls of your room, beyond the atmosphere of Earth, into the vast neighborhood of stars that surrounds your solar system. Here, in the local region of the Milky Way galaxy, you discover that you are not alone. Scattered throughout this cosmic neighborhood are silent companions. Invisible guardians that have watched over your corner of space for billions of years. These are the black holes of your galactic community, and they are closer than you might imagine. The nearest known black hole to Earth sits about 1,000 light-years away. This may sound impossibly distant, but in the scale of the galaxy, it is practically next door. If the Milky Way were the size of North America, this black hole would be sleeping quietly just a few cities away from you. This neighbor has a name that reflects its hidden nature. Scientists call it Gaia BH1, after the space telescope that helped discover it. For years, it remained completely invisible, revealing itself only through its gravitational influence on a companion star that orbits around it. Picture a dance partner you cannot see, spinning with a visible partner across a cosmic ballroom. The star you can observe moves in a perfect waltz, circling an empty point in space every 6 months. Its motion tells you that something massive must be there, something with the weight of 10 suns compressed into a space smaller than a city. This invisible partner never steals material from its stellar companion. It sits quietly in the darkness, content to let the star shine undisturbed. The two orbit each other in peaceful harmony, a cosmic marriage that has lasted for millions of years. But Gaia BH1 is not your only nearby neighbor. As telescopes become more sensitive and techniques improve, astronomers discover more and more of these hidden residents. Each new detection reveals another member of your extended cosmic family. Some of these black holes travel alone through space, solitary wanderers left behind by the deaths of ancient stars. They drift between star systems like cosmic nomads, invisible except for the rare moments when they pass in front of distant stars and bend their light. Others have found companionship among the living stars. They orbit red dwarfs, white dwarfs, and stars much like your own sun. Most of these relationships are gentle and stable, with the black hole serving as a silent partner that never demands attention. The black holes in your neighborhood come in different sizes, like houses in a suburban community. Some are compact and efficient, containing just a few times the mass of the Sun. Others are more substantial, holding the compressed matter of dozens of solar masses within their invisible boundaries. Each one tells a story about the history of your galactic region. They are the remains of massive stars that lived and died long before your solar system formed. These ancient stars forged heavy elements in their nuclear fires, scattering them into space when they exploded as supernovas. The black holes they left behind are like cosmic tombstones, marking the locations where stellar giants once blazed. But unlike ordinary graves, these markers will exist essentially forever, patient witnesses to the slow evolution of your galactic neighborhood. As your solar system travels its great orbit around the galactic center, you occasionally pass closer to some of these sleeping giants. Over millions of years, the distances between you and your black hole neighbors slowly change, like ships passing in the vast ocean of space. Sometimes, two of these invisible neighbors find each other in the darkness. They begin the billion-year dance you learned about in earlier chapters, slowly spiraling together until they merge in spectacular collisions that shake the fabric of spacetime itself. The gravitational waves from these local mergers are among the strongest that reach Earth. When black holes in your cosmic neighborhood finally unite, their signals arrive as powerful pulses that LIGO and other detectors can easily recognize. Scientists estimate that your region of the galaxy hosts hundreds or perhaps thousands of these invisible residents. Most remain completely hidden, detectable only when they happen to align perfectly with distant stars or when they find partners to dance with. This hidden population represents a vast reservoir of cosmic history. Each black hole contains information about the star that created it, compressed into mathematical relationships that describe the curvature of spacetime around the invisible boundary of no return. The black holes near you also play a role in shaping the structure of your galactic neighborhood. Their gravity influences the motion of nearby stars and gas clouds, helping to maintain the spiral arms of the Milky Way. They are like invisible pillars supporting the architecture of your cosmic home. Some of these neighbors may occasionally capture small asteroids or comets that wander too close to their gravitational wells. These unfortunate space rocks spiral inward, heating up and glowing briefly before disappearing forever beyond the event horizon. But you need not worry about these cosmic vacuum cleaners. The nearest black hole is far too distant to pose any threat to Earth. Its gravity at your location is weaker than the pull of a single grain of sand. You are perfectly safe in your orbital dance around the Sun. The discovery of black holes in your neighborhood has changed how scientists think about stellar evolution. These findings suggest that massive stars end their lives as black holes much more often than previously thought. The galaxy may be filled with millions of these invisible remnants. Future space missions will likely discover many more of these hidden neighbors. New telescopes and detection methods will reveal black holes that are currently too faint or too isolated to observe. Each discovery will add another piece to the puzzle of galactic structure and evolution. As you rest tonight, remember that you live in a cosmic community rich with invisible wonders. The darkness between stars is not empty, but populated with ancient guardians that have watched over your corner of the universe since long before Earth existed. These sleeping giants pose no danger to your world. They are simply part of the natural landscape of space, as normal and permanent as mountains or rivers are to the geography of Earth. They represent the final chapter in the lives of stars, the quiet aftermath of cosmic drama. Your journey through this populated galaxy continues every moment, carrying you past these invisible sentinels at speeds you cannot feel. You are traveling through a neighborhood where the most dramatic residents remain forever hidden, known only by their gentle influence on the visible world around them. But sometimes, in rare and beautiful moments, two of these hidden neighbors find each other and begin a dance that will end in cosmic celebration, announcing their union to the entire universe. In the deepest reaches of space, far from any world that could harbor life, two ancient giants prepare for their final dance. They have been circling each other for millions of years, patient partners in a cosmic ballet that began when the universe was much younger than it is today. These are not ordinary black holes. Each one contains the mass of dozens of suns, compressed into regions smaller than cities. They are the remains of the most massive stars that ever lived, stellar titans that burned bright and died spectacular deaths in the early days of cosmic history. For eons, they have maintained their distance, orbiting each other in wide, lazy circles that take thousands of years to complete. They are like two dancers in a vast ballroom, moving so slowly that you would need the patience of mountains to watch their waltz unfold. But as the ages pass, something beautiful and inevitable happens. The gravitational waves they create as they orbit carry away tiny amounts of energy with each pulse. Like a music box slowly winding down, their dance gradually loses momentum. the effect is almost impossibly subtle at first. Each orbit brings them perhaps a few inches closer, a change so small it would take millions of human lifetimes to notice. Yet this gentle decay never stops, never reverses, never pauses in its patient work. As the black holes spiral inward, their dance begins to quicken. What once took thousands of years now happens in hundreds. The gravitational waves they emit grow stronger, carrying away more energy, causing the spiral to tighten even faster. Imagine two figure skaters spinning together, holding hands and pulling closer. As they draw nearer to each other, they begin to spin faster and faster, their movements becoming more urgent and intense. This is exactly what happens to the dancing black holes as their billion-year courtship approaches its climax. When the giants finally draw within a few hundred miles of each other, their stately waltz transforms into something wild and magnificent. They race around each other dozens of times per second, moving at significant fractions of the speed of light. The space around them becomes a maelstrom of curved geometry. Time itself slows to a crawl in the deep gravitational wells they create together. If you could somehow watch from a safe distance, the final moments would appear to stretch like taffy, each second expanding into hours. But from the perspective of the black holes themselves, everything happens with lightning speed. Their event horizons, those invisible boundaries of no return, begin to stretch and deform like soap bubbles in a strong wind. The gravitational waves they create in these final moments become incredibly powerful. They carry more energy than all the visible light produced by all the stars in the observable universe. This tremendous output flows away from the dancing pair at the speed of light, spreading the news of their cosmic wedding across the galaxy. Then comes the moment of perfect union. The two event horizons touch and merge, like droplets of water coming together to form a larger drop. The collision happens so fast that if you could blink at the speed of light, you would miss it entirely. In that instant of contact, the two black holes cease to exist as separate entities. They become one, a single giant that contains all the mass and energy of both original dancers. The new black hole settles into its final form, ring-shaped waves rippling outward from its newly formed event horizon. But this is not a violent collision in the way you might imagine. There is no crash, no explosion, no debris scattered across space. Black holes have no solid surface to shatter, no material substance to break apart. They are pure gravity, pure geometry, pure curvature of spacetime itself. The energy released in their merger does not appear as light or heat or flying fragments. Instead, it flows away as gravitational waves, ripples in the fabric of reality that carry the complete story of this cosmic union to anyone who knows how to listen. These waves spread outward in all directions, like circles on a pond growing wider and wider. They pass through planets and stars as if they were not there, traveling at the speed of light across the vastness of space. The most powerful black hole mergers release more energy in gravitational waves than the Sun will produce in its entire 10 billion-year lifetime. This energy pours out in just a few seconds, making the collision site temporarily the most energetic place in the observable universe. Yet for all this tremendous power, the merger creates something paradoxically peaceful. The new black hole that emerges from the collision is actually simpler and more serene than either of its parents. All the complex details of the original dance have been smoothed away, leaving behind a perfectly round, perfectly symmetric giant. This newly born black hole will likely spend the rest of cosmic time in quiet contemplation. It may occasionally swallow a passing gas cloud or unlucky star, but it will probably never again experience anything as dramatic as the collision that created it. The gravitational waves from its birth will continue spreading across the universe for billions of years. They will wash over countless worlds, carrying their message of cosmic union to civilizations not yet born, to planets that have not yet formed around stars that have not yet begun to shine. When these waves finally reach Earth, they arrive as whispers softer than the gentlest breeze. The tremendous violence of the original collision has been diluted by distance and time, transformed into ripples so subtle that only the most sensitive instruments can feel their touch. Scientists who detect these cosmic whispers can read them like a story written in the language of curved space-time. The waves tell them exactly how massive the original black holes were, how fast they were spinning, and how far away the collision happened. Each detection adds another chapter to humanity's growing understanding of these cosmic giants. The universe, it turns out, is filled with dancing black holes, constantly finding each other and merging in spectacular unions that reshape the very fabric of reality. Some of these mergers happen between black holes of equal size, creating symmetric patterns in the gravitational waves they produce. Others involve a large black hole swallowing a smaller companion, like a cosmic whale consuming a fish made of pure gravity. The most spectacular mergers involve supermassive black holes, those giants that live at the centers of galaxies. When two galaxies collide and eventually merge, their central black holes begin a dance that can last for millions of years before culminating in a union that outshines the birth of stars. Tonight, as you rest in the gentle quiet of your world, remember that somewhere in the cosmic darkness, new giants are beginning their ancient dance. Patient partners are finding each other across impossible distances, beginning journeys that will end in embraces more powerful than anything you can imagine. The universe is constantly creating these invisible storms of gravity, writing poetry in gravitational waves that travel faster than light and last longer than civilizations. Take a moment to feel the solid ground beneath you, the gentle pull of Earth's gravity holding you safe and secure. You rest on a world that has spun peacefully through space for over 4 billion years, never once disturbed by the cosmic violence that unfolds in the distant universe. This safety is not an accident. It is a gift of distance, a blessing of the vast emptiness that surrounds your solar system. The space between stars, which might seem lonely and cold, is actually your greatest protector. Consider the incredible collision you just imagined, where two black holes merge in a burst of energy more powerful than all the visible stars combined. Such an event, happening anywhere in your cosmic neighborhood, would seem like it should affect your world dramatically. Yet when the gravitational waves from these cosmic catastrophes reach Earth, they arrive as touches so gentle they barely disturb a single atom. The tremendous violence of the original event has been diluted by billions of miles of empty space, transformed into whispers that rock your planet like the softest lullaby. This protective distance works in mysterious ways. Imagine shouting at the top of your lungs in a vast canyon. Your voice echoes off the walls, but by the time it returns to you, it has become a faint whisper. Space does something similar to gravitational waves, spreading their energy across such enormous distances that even the most powerful cosmic events arrive as gentle caresses. The nearest black holes to Earth sit comfortably far away, like distant lighthouses on a cosmic shore. The closest one lies about 1,000 light-years from your home. If you could travel at the speed of light, it would take you 1,000 years to reach this sleeping giant. But even this nearby neighbor poses no threat to your world. Its gravitational pull at Earth's location is weaker than the attraction between you and a grain of sand on a distant beach. You are perfectly safe in your orbital dance around the Sun, protected by the simple physics of distance. This same protective distance shields you from all the cosmic violence that fills the universe. Supernovas explode with the power of billions of suns, but the nearest one to Earth is so far away that its light would appear no brighter than an ordinary star in your night sky. Gamma-ray bursts, the most energetic explosions known to science, release more energy in seconds than the Sun will produce in its entire lifetime. These cosmic cannons can sterilize entire regions of space with their deadly radiation. Yet the vast majority of them happen in distant galaxies, so far away that they appear to your telescopes as mere flickers of light. Even if such an explosion occurred in your own galaxy, the chances of Earth being in its path are extraordinarily small. The universe is so large and your world so tiny that cosmic catastrophes almost always miss you by enormous margins. The solar system itself provides additional layers of protection. You orbit at just the right distance from the Sun to enjoy its warmth without being scorched by its radiation. The giant planets, Jupiter and Saturn, act like cosmic vacuum cleaners, using their strong gravity to sweep up asteroids and comets that might otherwise threaten Earth. Your planet's magnetic field creates an invisible shield that deflects the harmful particles flowing from the Sun. The atmosphere above you burns up most meteors before they can reach the surface, turning potential dangers into beautiful shooting stars. Even the timing of your existence provides protection. You live during a period when the Sun burns steadily and calmly, neither too hot nor too cold for life to flourish. This stellar stability will continue for billions more years, giving life on Earth vast stretches of time to evolve and explore. The Milky Way galaxy itself is a haven of relative calm. You orbit in one of the spiral arms, away from the crowded and dangerous galactic center. Here, stars are spread far apart, giving each solar system plenty of room to exist in peace. Your location in the galaxy also keeps you away from the most active regions where massive stars explode frequently. You live in what astronomers call the galactic habitable zone, a cosmic suburb where conditions remain stable for billions of years. The distances that protect you are so vast they challenge human imagination. Light from the nearest star takes over 4 years to reach Earth. Light from the center of your galaxy takes 26,000 years to arrive. Light from distant galaxies has been traveling toward you since before the Earth even existed. These cosmic distances mean that you observe the universe as it was in the past, not as it is today. When you look at stars, you see them as they were years or centuries ago. The most distant objects you can observe show you the universe as it appeared billions of years ago, when it was young and very different. This natural time delay means that even if something catastrophic happened to a nearby star today, you would not know about it for years. By the time the light or gravitational waves reached Earth, you would have had plenty of warning and time to prepare. The protective power of distance extends beyond just physical safety. It also gives you perspective on your place in the cosmic story. From your vantage point on Earth, you can observe the entire universe spread out before you like a vast museum of space and time. You can watch the peaceful dance of planets in your solar system, observe the steady burning of nearby stars, and peer deep into space to witness the birth and death of galaxies billions of light years away. Distance transforms you from a participant in cosmic drama into a safe observer of its magnificent unfolding. The gravitational waves that wash over Earth tell stories of events that happened when the universe was very different from today. Some of these cosmic collisions occurred before your solar system formed, before complex life evolved on Earth, before humans looked up at the stars and wondered about their place in the cosmos. Yet these ancient events reach you now as gentle reminders of the dynamic universe you inhabit. They connect you to cosmic history while never threatening your peaceful existence on this small blue world. The safety of distance allows you to appreciate the universe's power without fearing it. You can marvel at the energy released when black holes collide, knowing that this violence will reach you only as whispers in spacetime. You can contemplate the deaths of massive stars, secure in the knowledge that their explosions happen too far away to disturb your world. Tonight, as you rest under the protective blanket of space and time, remember that you live in a universe designed for your safety. The vast distances between objects, which might seem cold and empty, are actually warm embraces that keep you secure in your cosmic home. Even the most dramatic events in the universe arrive at your doorstep transformed into gentle messages, carrying news of distant wonders without disturbing the peaceful rhythm of your daily life. In the quiet darkness of your room, it might seem strange to think of black holes as gentle caretakers. These invisible giants, which swallow light itself, actually serve as the universe's most patient gardeners, tending cosmic landscapes with careful precision. At the heart of your own galaxy, the Milky Way, sits such a guardian. This supermassive black hole weighs as much as 4 million suns, yet it maintains perfect balance in its role as galactic shepherd. For billions of years, it has been quietly organizing the stellar neighborhood you call home. Imagine a master gardener working with a plot of land larger than you could ever walk across. This gardener does not plant with hands or tools, but uses the invisible force of gravity to shape cosmic flowerbeds where stars will bloom. The black hole at your galaxy center works exactly like this, though its garden stretches across 100,000 light-years. The supermassive black hole creates what scientists call the galactic bulge, a dense concentration of older stars that forms the central hub of the Milky Way. Like a city center surrounded by suburbs, this region organizes the entire structure of your cosmic home. The black hole's gravity reaches far beyond this central region, influencing the motion of stars throughout the galaxy. It helps maintain the graceful spiral arms where young, hot stars light up clouds of gas and dust. These spiral patterns, which give your galaxy its characteristic pinwheel shape, exist partly because of the central black hole's organizing influence. But the cosmic gardening extends far beyond simple organization. Black holes actively participate in the cycle of stellar birth and death that keeps galaxies alive and growing. They are not just destroyers, as they might first appear, but essential partners in the ongoing creation of new worlds. When gas and dust spiral into a black hole, they do not simply vanish without a trace. As this material falls inward, it heats up to incredible temperatures, glowing brighter than entire star clusters. These accretion disks, as scientists call them, become cosmic lighthouses that can be seen across billions of light-years. The energy released by material falling into black holes often creates powerful jets of particles that stream out in opposite directions at nearly the speed of light. These jets plow through space for thousands of light-years, clearing away excess gas and dust that might otherwise prevent new stars from forming. Think of it as cosmic pruning. Just as a gardener trims overgrown branches to help a tree grow stronger, black holes remove excess material from their galactic neighborhoods. This process, called feedback, helps regulate star formation throughout the galaxy. Without this gentle pruning, galaxies would use up all their gas too quickly, creating so many stars at once that they would burn out and die before planets like Earth could form. The black holes act as cosmic thermostats, keeping star formation at just the right rate to sustain galactic life for billions of years. The relationship between black holes and their galaxies is so intimate that they grow together over cosmic time. As a galaxy accumulates more stars and gas, its central black hole also gains mass. The two partners in this cosmic dance maintain a delicate balance that has persisted for most of the universe's history. This partnership reveals itself in a beautiful mathematical relationship. The mass of a galaxy's central black hole is always proportional to the mass of the galaxy's central bulge of stars. It is as if the galaxy and its black hole are two parts of a single cosmic organism, growing and evolving together. When two galaxies merge, their central black holes eventually find each other and begin the billion-year dance that ends in gravitational waves. But even this apparent destruction serves a creative purpose. The merged galaxies often experience bursts of new star formation, as the collision compresses gas clouds and triggers the birth of countless new suns. The black holes that result from these galactic mergers become even more effective gardeners, capable of shaping larger cosmic territories. They help create the vast structures you see in the universe today, the filaments and walls of galaxies that stretch across hundreds of millions of light-years. On smaller scales, stellar mass black holes also serve as cosmic gardeners. When massive stars explode as supernovas, they scatter heavy elements throughout space. The black holes left behind by these explosions continue to influence their surroundings for billions of years, stirring up nearby gas clouds and triggering the formation of new stars. These stellar remnants also serve as cosmic recycling centers. Material that falls into them carries information about the chemical composition of their surroundings. In a sense, black holes become libraries of galactic history, storing data about the evolution of their cosmic neighborhoods. The gardening work of black holes operates on timescales that dwarf human experience. What seems like destruction from our brief perspective is actually careful cultivation when viewed across cosmic ages. The patient work of these invisible gardeners has made possible the rich, complex universe you inhabit today. Your solar system formed in a region of the galaxy that has been carefully tended by black holes for billions of years. The heavy elements in your body, forged in the hearts of ancient stars, were distributed throughout space by processes involving black holes. The stable galactic environment that allowed your sun to burn peacefully for billions of years exists partly because of black hole feedback. Even the gravitational waves that wash over Earth carry news of this ongoing cosmic gardening. Each detection tells of black holes merging to create new, more powerful galactic shepherds. These waves are like status reports from the universe's maintenance crew, letting you know that the cosmic garden is being well tended. The black holes in distant galaxies continue this gardening work across the observable universe. Telescopes reveal galaxies whose central black holes are actively feeding, creating brilliant quasars that outshine hundreds of billions of stars. These cosmic lighthouses show you galaxy formation in action, gardening work happening in real time. Other galaxies show the results of mature gardening, with their central black holes resting quietly after eons of careful cultivation. These sleeping giants have shaped their galactic homes into stable, long-lived systems where planets can form and life might eventually emerge. The universe you observe today is the product of billions of years of this cosmic gardening. Every galaxy bears the signature of black hole influence, from the smallest dwarf galaxies to the largest elliptical giants. The diversity and beauty of the cosmic landscape reflects the patient work of these invisible caretakers. As you rest tonight, remember that you live in a universe where apparent opposites work together in perfect harmony. Destruction and creation, darkness and light, death and birth, all participate in the same eternal cycle that has been unfolding since the cosmos began. The black holes that might seem like cosmic monsters are actually gentle gardeners, tending the vast spaces between stars with the same care that nature tends the gardens of Earth. Their work continues even now, shaping cosmic neighborhoods where future generations of stars and planets will bloom. Perhaps somewhere in this carefully tended universe, other worlds circle other suns, and other minds contemplate the gentle paradox of creation emerging from apparent destruction. Let your mind wander into the realm of cosmic what-ifs, where imagination meets the careful mathematics of physics. Picture, for a moment, a scenario that exists only in the safe space of thought. What if two black holes found each other not in the distant depths of space, but somewhere much closer to your small blue world? This is not a prediction or a warning, but simply an exploration of possibilities. Like reading a story about dragons or unicorns, you can visit this imaginary scenario knowing it remains safely in the realm of wonder, not reality. Imagine that astronomers discover two black holes, each about 10 times heavier than the Sun, beginning their spiral dance just a few hundred light-years from Earth. This is still incredibly far away, mind you. Even traveling at the speed of light, it would take centuries to reach them. Yet in cosmic terms, such neighbors would be practically next door. The first thing scientists would notice is time. These cosmic dancers would have millions of years to complete their waltz before reaching their final embrace. This gives your world countless generations to observe, study, and prepare for their eventual collision. During these early phases of their dance, the black holes would remain completely invisible to your eyes. No telescope could see them directly. They would reveal themselves only through their gravitational influence on nearby stars, causing distant suns to wobble slightly in their courses through space. As the eons pass and the black holes spiral closer together, their dance would begin to accelerate. Gravitational waves would flow outward from their cosmic ballroom, carrying energy away from the pair and causing them to draw ever nearer to each other. These waves, when they first begin reaching Earth, would be extraordinarily gentle. They would stretch and squeeze space by amount smaller than the nucleus of an atom. Your world would rock on these cosmic swells like a leaf floating on perfectly calm water. Advanced civilizations on Earth, if they still existed after millions of years, would have ample time to study this approaching cosmic event. They would build gravitational wave detectors far more sensitive than anything that exists today, listening to the slowly intensifying song of the dancing black holes. The waves would tell a complete story as they grew stronger over time. Scientists could measure the exact masses of the two black holes, the shape of their orbits, and precisely when their final collision would occur. They would have hundreds of thousands of years to prepare for that climactic moment. As the final centuries approach, the gravitational waves reaching Earth would become strong enough to detect with simpler instruments. The black holes would be racing around each other hundreds of times per second, their invisible dance creating ripples that shake the very foundation of spacetime. But what would it mean for your world when these nearby giants finally embrace? The collision itself would release more energy in gravitational waves than the Sun produces in light over its entire 10 billion year lifetime. This tremendous power would flow outward at the speed of light, reaching Earth within a few hundred years of the actual merger. When those waves arrive, they would be far stronger than any gravitational signals Earth has ever experienced. Instead of stretching space by infinitesimal amounts, they might change distances by fractions of a millimeter. Laboratory instruments would dance visibly to the rhythm of the cosmic collision. Yet even these enhanced gravitational waves would pose no direct danger to your world. They would pass through Earth like gentle ocean swells, stretching and squeezing the planet by tiny amounts. Buildings might sway imperceptibly. Lakes might slosh back and forth with microscopic tides. But life would continue undisturbed. The more dramatic effects would be indirect and beautiful. The passage of such strong gravitational waves might trigger small earthquakes as they flex the Earth's crust. Aurora-like phenomena might dance in the sky as the waves interact with your planet's magnetic field in ways never before observed. Sensitive scientific instruments around the world would register the event as the most significant gravitational wave detection in human history. The signal would contain detailed information about the nature of space and time themselves, providing new insights into the fundamental workings of the universe. The waves would also carry a profound message about cosmic time scales. The black holes whose collision created these waves would have begun their dance long before complex life existed on Earth. Their story would span the entire history of your world, finally reaching its conclusion in your cosmic present. But perhaps the most remarkable aspect of such an event would be its rarity. Even in this imaginary scenario, you would be witnessing something that happens perhaps once every million years in any given region of the galaxy. You would be observing a cosmic event so rare that it might never happen again in your galactic neighborhood. The aftermath would be equally fascinating. The two black holes, having merged into a single giant, would settle into their new form over the course of several minutes. The gravitational waves would gradually fade, like the last notes of a cosmic symphony echoing across space. The newly formed black hole would be slightly less massive than the sum of its parents, with the missing mass having been converted to gravitational wave energy. This cosmic alchemy, turning matter directly into ripples in spacetime, would demonstrate Einstein's famous equation in the most dramatic way possible. In the years following the collision, astronomers would search the sky for any visible signs of the event. They might discover that nearby stars had been slightly disturbed in their orbits, or that gas clouds in the region showed subtle signs of having been shaken by the passing gravitational waves. The scientific discoveries from such an event would revolutionize your understanding of black holes, gravity, and the nature of space itself. Textbooks would be rewritten. New theories would emerge. The field of gravitational wave astronomy would advance by decades in a single moment. Yet for all its cosmic significance, life on Earth would continue much as it always has. The sun would still rise each morning. Seasons would still change. The fundamental rhythms of your world would remain unchanged, touched but not disrupted by the distant thunder of colliding giants. This imaginary scenario reveals something beautiful about the universe you inhabit. Even the most dramatic events in the cosmos operate according to natural laws that protect smaller, more delicate structures like planets and the life they harbor. The universe seems designed with built-in safety mechanisms. Distances that might seem cold and empty actually serve as cosmic cushions, absorbing and diluting even the most violent events. Time itself acts as a gentle buffer, spreading cosmic drama across eons rather than moments. In this carefully balanced cosmos, you can contemplate the most extreme phenomena while remaining safely cradled in your small corner of space and time. The universe allows you to be both participant and observer, touched by cosmic events but never overwhelmed by them. As your mind returns from this journey into cosmic what-ifs, remember that you live in a universe where even the most dramatic possibilities unfold according to rules that favor life, consciousness, and the quiet contemplation of cosmic mysteries. The real black hole collisions happening throughout the universe right now are creating gravitational waves that will reach Earth as gentle whispers, carrying stories of distant dances performed by invisible partners in the vast theater of space. Let your breathing slow and deepen as your mind drifts back to the quiet comfort of your room. The cosmic journey you have taken tonight has carried you across billions of years and countless light years, yet you return to find yourself exactly where you started. Safe, warm, and perfectly placed in the vast tapestry of space and time. The black holes that dance in distant galaxies, the gravitational waves that whisper across the universe, the ancient stars that collapsed into infinite mystery, all of these cosmic wonders exist in perfect harmony with your small, peaceful world. They are not separate from your daily life but part of the same magnificent story of which you are an essential character. Think of the universe as a vast, gentle ocean in which your solar system floats like a small island of warmth and light. The cosmic storms that rage in distant regions send only the softest swells to rock your peaceful shore. You are held safe in a cosmic cradle that has protected life on Earth for billions of years. This protection is not accidental but woven into the very fabric of reality. The same laws that govern the collision of black holes also guide the formation of planets, the evolution of life, and the development of consciousness that allows you to contemplate these mysteries. Every atom in your body was forged in the nuclear fires of ancient stars. The calcium in your bones, the iron in your blood, the oxygen you breathe, all were created in stellar furnaces that burned billions of years ago. When those massive stars died and became black holes, they scattered these precious elements throughout space, making your existence possible. The gravitational waves that have washed over you throughout your lifetime carry the fingerprints of these cosmic ancestors. Each gentle ripple in spacetime connects you to the ancient dances of collapsed stars, making you part of a cosmic family that spans the entire history of the universe. Your planet orbits in what astronomers call the Goldilocks zone, not too hot and not too cold, but just right for liquid water and the chemistry of life. This perfect placement is maintained by the same gravitational forces that cause black holes to spiral together across the cosmos. The sun that warms your world burns with steady consistency, providing the stable energy that life requires. This stellar reliability will continue for billions more years, giving consciousness on Earth vast stretches of time to grow, explore, and understand the universe that created it. Even the moon that watches over your sleep plays a role in this cosmic harmony. Its gentle pull creates the tides that may have helped life emerge from ancient oceans. Its presence stabilizes Earth's rotation, ensuring consistent seasons and climate patterns that support the delicate balance of living systems. The galaxy that contains your solar system rotates with stately precision, carrying you on a grand journey around the galactic center. This motion takes place so slowly that hundreds of millions of years pass between complete orbits. You are a passenger on a cosmic ship that sails through space with the patience of eternity itself. The black holes scattered throughout your galaxy serve as invisible lighthouses, marking the locations where massive stars once burned. They help maintain the spiral structure that makes the Milky Way a safe haven for star formation and planetary systems like your own. Even the expansion of the universe itself works in your favor, creating the vast distances that protect you from cosmic violence while allowing light from distant stars to reach your eyes. This cosmic expansion ensures that you can observe the universe's history while remaining safely isolated from its most dramatic events. The gravitational waves that scientists detect on Earth arrive as whispers from the distant past, carrying news of black hole collisions that happened when the universe was young. These ancient messages travel across space and time to reach you at the perfect moment when humanity has developed the technology to hear them. This timing is part of a beautiful cosmic coincidence. You live at exactly the right moment in cosmic history to witness the universe's secrets being revealed through gravitational waves. Earlier, and the technology would not have existed. Later, and the universe might have evolved beyond the era of frequent black hole mergers. Your existence depends on countless cosmic accidents that all worked out perfectly. If stars burn differently, if gravity were stronger or weaker, if the universe expanded at a different rate, worlds like yours might never have formed. Yet here you are, conscious and curious, able to contemplate the very forces that brought you into being. The black holes that seemed so mysterious and distant at the beginning of your journey are now revealed as integral parts of the cosmic ecosystem that sustains your world. They are recyclers of stellar material, sculptors of galactic structure, and creators of the gravitational waves that connect you to the deepest rhythms of space and time. As you settle into sleep tonight, let yourself feel held by the vast forces that cradle your existence. The same gravity that causes black holes to dance also keeps your feet planted firmly on Earth. The same nuclear processes that power stellar explosions also warm your world with gentle sunlight. The universe that contains such dramatic violence also provides such perfect peace. It creates black holes that can tear apart space itself, yet it surrounds you with conditions so stable that life can flourish for billions of years. This cosmic balance reveals a universe that favors complexity, consciousness, and the quiet contemplation of its own mysteries. Your dreams tonight may carry you back to the cosmic dances you have witnessed. Perhaps you will find yourself floating between stars, listening to the gravitational music created by invisible partners spinning through the darkness. Perhaps you will visit the ancient past, watching massive stars collapse into the black holes that now send waves across the universe. Or perhaps you will simply rest deeply, held by the knowledge that you are part of something infinitely larger and more beautiful than you can fully comprehend. The universe has spent billions of years preparing the stage for your existence, creating the perfect conditions for life, consciousness, and wonder. The black holes that collide in distant regions of space do so as part of the same cosmic story that includes your birth, your thoughts, your dreams, and your peaceful rest. You are not separate from the universe but woven into its very fabric, a conscious thread in the cosmic tapestry that connects all things across space and time. Sleep now, knowing that you are exactly where you belong in the grand design of existence, safely cradled in a universe that dances with infinite mystery and infinite care.